Ever pondered the possibility of life beyond our blue planet? We're not alone in this curiosity. For ages, humans have gazed upon the cosmos, contemplating the existence of extraterrestrial life. With a universe so vast and filled with countless stars, the question arises, why haven't we found any evidence of alien life? Surely, amidst the celestial sprawl, there must be other life forms, right? So, where are they? Let's dive into the Fermi Paradox to better understand this cosmic conundrum. Imagine yourself in a cosmic cafe, sipping a cup of cosmic coffee with Enrico Fermi. Now let's talk about a paradox. A paradox is a statement or proposition that, despite sound reasoning from acceptable premises, leads to a conclusion that seems senseless or logically unacceptable. One such paradox is the Fermi Paradox, named after the physicist Enrico Fermi. Enrico Fermi, a man of immense intellect, once asked a simple question during a casual conversation with his colleagues, "Where is everybody?" This question, seemingly simple at first glance, delves deep into the mysteries of our universe. What Fermi was really asking was, if there are a multitude of technologically advanced civilizations in the universe, why have we not heard from them? You see, the universe is old. Really old. It's been around for about 14 billion years. Our galaxy, the Milky Way, is also quite ancient, about 10 billion years old. With billions of stars similar to our sun, many of them much older, there should be a high probability that intelligent life has evolved elsewhere. And if these civilizations are older than ours, they should be far more technologically advanced. So, if these civilizations exist, why haven't they visited us? Or at the very least, why haven't we detected any signals or signs of their existence? This is the essence of the Fermi Paradox. The contradiction between the high probability of extraterrestrial life, given the vast number of stars and planets, and the lack of contact or evidence for such civilizations. The paradox becomes even more intriguing when we consider the concept of time. Given enough time, it's thought that a civilization could colonize the galaxy, even at the slow pace of our current technology. Yet we see no evidence of such galactic colonization. It seems like a logical paradox, doesn't it? But don't worry, there's more to explore. Next stop, meet Frank Drake and his famous equation. This mathematical formula, my friends, is not just a mere amalgamation of symbols and coefficients, but a beacon that illuminates our quest to find extraterrestrial life. The Drake equation, named after the astrophysicist Frank Drake, is a probabilistic argument used to estimate the number of active, communicative extraterrestrial civilizations in our galaxy, the Milky Way. Now let's delve into the variables that make up this fascinating equation. First up is R star, the average rate of star formation per year in our galaxy. Next is FP, the fraction of those stars that have planetary systems. Ni follows, representing the number of planets per solar system with an environment suitable for life. The fourth factor, FL, is the fraction of suitable planets where life actually develops. Phi comes next, denoting the fraction of life that develops into intelligent beings. FC is the fraction of civilizations that develop a technology that releases detectable signs of their existence into space. Bringing up the rear is L, the length of time such civilizations release detectable signals into space. Each of these variables plays a crucial role in the Drake equation. They collectively help us estimate the number of civilizations in our galaxy that could be broadcasting signals we might be able to detect. Now here's where it gets interesting. Even with conservative estimates, the Drake equation suggests there could be a substantial number of technologically advanced civilizations out there, right at this moment. However, this leads us to a conundrum. If the Drake equation suggests a high likelihood of extraterrestrial civilizations, then why haven't we detected any definitive signs of their existence? Indeed, the Drake equation, while providing a scientific approach to the search for extraterrestrial intelligence, also deepens the mystery surrounding the apparent silence of the cosmos. So, with the Drake equation suggesting a high likelihood of alien civilizations, the mystery deepens. Why then does the universe remain silent? A question that has been echoing in the minds of scientists and dreamers alike for years. It's an enigma that's as vast as the cosmos itself. So why does the universe seem so quiet? Well, there are several theories that attempt to explain this cosmic hush. One such theory suggests that perhaps these extraterrestrial civilizations are simply too far apart. The universe is an enormous place after all. With galaxies scattered like grains of sand on an infinite beach, it's possible we're just too distant for any meaningful contact. Another theory speculates that perhaps these civilizations are consciously avoiding us. It's not entirely outlandish to think that an advanced civilization might choose to remain hidden, either for their safety or ours. Then there's the somewhat somber theory that these civilizations may have already gone extinct. The lifespan of a civilization, much like that of a star, could be a blink of an eye in the grand cosmic timescale. Lastly, it's also possible that we humans are simply not listening correctly. Maybe our technology is not yet sophisticated enough to pick up the signals they're sending, or we're not looking in the right place or at the right time. The universe, it seems, is holding its cards close. And maybe, just maybe, it's waiting for us to play our hand right before showing its own. In the end, the question remains, where is everybody? We've journeyed through the fascinating landscape of cosmic quandaries, from the Fermi Paradox's stark contradiction to the Drake equation's tantalizing possibilities. We've probed the silence of the cosmos, a silence that seems almost eerie in the face of the high probability of extraterrestrial life. We've examined the paradox that lies at the heart of our quest, a universe so vast, so ripe with potential for life, yet so eerily silent. We've grappled with the contradiction between the high likelihood of alien existence, as suggested by the Drake equation, and our lack of contact or evidence, a contrast that the Fermi Paradox starkly highlights. Yet the cosmic enigma persists. It's a riddle that continues to tease us, to challenge us, to inspire us. As we continue to explore the cosmos, we can only hope to one day unravel this enigma. Until then, we remain earthbound, gazing at the stars and pondering the question, are we alone?